Hello, all. Um, Good morning or afternoon, or evening, depending on where you're at. Thank you very much for joining. What we're doing today is this is meant to be really a kickoff workshop just for a couple hours here for a collaborative manuscript that we are developing openly with you all and likely some additional folks as well. Very excited to do that. We've done this a few times, and it's a cool experience to start to bring lots of minds to bear on science problems simultaneously. It's quite fun. So start just quickly here with the agenda, and I'm just checking the chat. Okay, thank you, Bree, for dropping the agenda. That should be available to y'all. If you have a hard time accessing it, please let us know. But basically, there's contact information. First of all, an email to reach out for anything that comes to mind. We're going to go over some intro. So we're doing right now. I'll share some slides in just a minute. We're going to go do a little icebreaker, talk about some governance. That's very important, especially as we develop manuscripts collectively as a community. Got to have some expectations and norms. Then we're going to talk more science in the second hour. We have a storyboard that's already built out, but that's very much meant to be influenced by you all. We're gonna have some small group breakout time, as well as time to provide some comments, and then some group discussion, and then some tangibles, like how are we moving forward. So let's start at the first piece then. And so you can see this slide deck. All the links should be in the agenda for all the documents that we're showing. If there's something missing, let us know. The slide deck, you can see there's some slides hidden here. We're not going to go over those. They're there if you want to go check them out. But I'm going to just present the normal view. Okay, so, no, I just messed that up. My bad. Sorry. There we go. Okay, so yeah, this collaborative manuscript, this icon-based science, I know many of you have heard about it multiple times. Again, contact info, WHONDRS website. There'll be a few of us presenting today, Brianne Forbes, Stefan Gary, Amy Goldman, and myself. The work from our side is funded by the U.S. Department of Energy through their Environmental System Science program and their Small Business Innovation program. Very much appreciate that. The recording is going on the WHONDRS of this is going on the WHONDRS YouTube, and we'll make that globally, publicly available. Okay, so again, like, what are we really doing today? We're trying to initiate writing and build community. Building community is a key part of this whole exercise, and really one of the most fun parts in my view. So, what is our manuscript goal? This will be shaped, yes, but in general, we're trying to understand and predict sediment respiration rivers across the CONUS. That's what this whole project is about. Our approach is to do this with an interdisciplinary team, i.e. you all. Today, we're trying to inspire by summarizing some science, trying to lay a real foundation in terms of an overview of the storyboard we've built out. That's been shared with you already via email. Trying to enable, trying to share ideas, hear your ideas, discuss. This is very much meant to be a collaborative. We got someone that could go on mute, thank you. And trying to lead, like, going to make this tangible and get a real path forward. Team building is really important for this. We have to have rapport, we have to have trust, we have to have expectations, and really be sincerely invested in in a team approach. This isn't about any one of us, it's about all of us. So then, for just in case there's anyone that hasn't been tied into the science so far, I'm just going to give a couple slides to orient. Just want to make sure we're not leaving anybody behind. So those of you that have seen it before, sorry, or maybe it's useful to hear it again. But very briefly, what are we doing? Well, the motivation is we're focused on the sediment respiration from rivers across the contiguous US. And why? Well, those sediments are part of hypereoic zones where surface waters and groundwaters mix, very biogeochemically active domains. But really, they vary in their contributions to overall river respiration from anywhere from 3 to 99%. Basically, the maximum range that is theoretically possible has been observed. We don't have a model or mechanistic or conceptual understanding robust enough to help us predict this variability across very diverse rivers, continental to global scales. So what are we trying to do? Well, we're not going to completely solve that problem. That is not the goal. We're moving towards it, though, of trying to understand and predict sediment respiration, as I already said, across the contiguous US. So that's kind of where we're starting. How are we doing this? So Stefan, who is at Parallel Works, a small business, took open data that were generated through crowdsourcing efforts through our WHONDRS consortium. Many of you likely contributed to those samples and those data. Thank you. He took those data that are they're published in public and built machine learning models based on them to predict sediment respiration across the CONUS, use them then to turn the corner into AI and use the artificial intelligence to then guide us to where to go get new samples, new data to test those models and improve them. We've been crowdsourcing those samples with, again, likely many of you. Those data every month, we generate new respiration rates from across the US, and those data are then used to test, evaluate, and then fully rebuild the machine learning model. Stefan has set this up to be fully automated now. And so we've been going through this iterative cycle. We've gone through 11 or 12 of these cycles. The model has gotten substantially better. I think we're sitting at about, we started at about the ability to explain about 10% of the variation across the US, and now we're getting up close towards 60%. So nowhere close to 100, but in my view, that's a huge improvement in model performance. And so this whole cycle, this whole approach, kind of the methodology of this, there's a separate paper that's being developed that will be submitted first. Stefan and Tim Scheibe, who are here, they're leading that paper. As it says here in the left-hand side, that's going to detail the machine learning methods, the algorithms at the model engineering. So that's kind of laying a very practical foundation for us here to build on and do a little bit more of the conceptual science. So that's kind of the approach we've been taking. And again, this is a workshop to kick off a manuscript based on this. And so that's all. There's other hidden slides you can go look at if you like in the slide deck that show model performance and things like that. And we've presented this many times. And so we're gonna then just briefly touch on what is the structure of the manuscript we're envisioning. And you all have the link to the storyboard. We are gonna go over that later. I'm just gonna touch on this briefly right now. So I already talked about the motivation. And we have 5 science questions at the moment. And part of today is meant to get feedback and iterate and improve those questions, change directions as we need to. And that iteration, that improvement will continue over the next couple of weeks, asynchronously. So the questions range from looking at respiration rate distributions. We have, I don't know, 500 or 600 rate measurements now across the US. Pretty robust distributions. What do they look like? What's the shape? How they've been changing through time? What are the spatial patterns in respiration rates? Do we see latitudinal or longitudinal gradients, that kind of stuff? How is the model performance and model guidance changing through time? Like this is this very iterative process. It's quite unique. And so we want to look at that and understand those spatiotemporal dynamics, if you will, in where the model's been guiding us to go. The model performance itself, how has that been changing through time? I just mentioned briefly how it's been changing at a high level. And then lastly, that's all kind of characterization, so to speak. But then, okay, what are the most explanatory variables? Let's move beyond the pure black box of the machine learning to pull out hopefully some conceptual inferences about what are the key governing aspects of these systems. And so, okay, well, what are the implications doing this? Well, okay, we can now do a pretty good job of predicting sediment respiration across the CONUS, including pretty extreme hotspots, very, very fast rates of respiration. And hopefully we will be able to say that, okay, we learned that these key things likely lead to these kind of extreme hotspots at the Kona scale. It just says XXX right now because we haven't done the analysis. That's part of this process that we're all launching into here. So that we're going to come back to this and spend quite a bit of basically the whole second hour around the manuscript. I just wanted to kind of briefly get people's minds there. So now what we're going to do, I think we're actually on time so far. Bree, would you like to share this little activity?
Yeah, so for a little icebreaker for people to get to know each other, we're going to break into small breakout rooms and we're going to do this I like, I hope, I wonder activity. So we have a Google form that you can access the link through the agenda, and each person will contribute one of these forms within your subgroups. So an example of this is I like to co-write with the team. I hope the manuscript can be completed by the end of this calendar year. And I wonder if regular small group co-writing sessions could help to accelerate progress. So right now I am just assigning people to breakout rooms and I'll go ahead and open them in 1 second.
Awesome, thank you. And our intent here is this I like, I hope, I wonder is just a vehicle for people to share some thoughts. The Google form is tricky or whatever for you. Don't worry about it. Just share who you are, introduce yourselves, share some what you're thinking about and whatnot. This is just kind of a fun, hopefully a fun way to kind of get to know each other. And it should automatically take people. Yeah.
Yeah, once I open them. And I have it set for 10 minutes. Is that still on board with that? Okay, cool.
I think so. So people, I
I'm
think,
opening them right now.
yeah, then you'll automatically get pulled back here. So just have some fun, meet some people, chill, talk science, talk about yourselves, and enjoy building community. We'll see you back here in about 10 minutes. Oh boy, here comes everybody.
Okay. Okay.
Awesome. Okay. Hi. Well, welcome back.
Yes, welcome back, everyone. Please remute yourselves if you haven't already. And we'll just give it another second. I think we have everyone again. Oh, the screen keeps changing, so I'm not quite sure. Just give it another moment. I'm Amy, and I'm gonna talk through the next part here. So I'm gonna share my screen. But I hope you all got to know each other a little bit and get a little bit excited as well about working together. And what we're going to talk through now is some of the governance pieces. So we saw one of the responses that came in was asking about, in the Google form, was asking about some do's and don'ts and how people are going to be working together. So it seemed like a great segue into this section that we had planned. So in the agenda is the link to the code of conduct. And if you see at the top, it says, please add comments or edits by July 7th. So we're giving this out for feedback. This is not considered the final code of conduct. So please do give your thoughts. We already have one comment in there, which is great. So I'm just going to go through sort of briefly each section. And then you can read it in more detail later if you haven't yet. So the first section here, we have expected behavior. And so this talks about being respectful, being inclusive, communicating openly, avoiding personal attacks. And it also specifically calls out some leadership team expectations as well that are in line with that. And then we have the next section, unacceptable behavior. And that calls out things like harassment, intimidation, discrimination, plagiarism, falsifying results. And then we have consequences to hold people accountable. And so there are two pieces to that. One is that people are expected to stop any unacceptable behavior when asked, and that the leadership team can remove participants if they're not following the code of conduct. And then we have some reporting mechanisms as well. So people can report anything to the folks who are leading this call today. So James, myself, Stefan, and Bree. We also have an anonymous Google form if you'd prefer to report things anonymously. And so that I'll just click over, looks like this. You can see at the top, it says that the email is not shared. And it's very short. It just has two pieces: describe your concern and describe any actions that you would like to see happen to address your concern. And then lastly, if you have any reporting that you'd like to do that you don't want to go to the leadership team, perhaps it's about the leadership team, you can also report things to James's manager, who is completely separate from this manuscript. And so his email address is here, and it's also at the top of the anonymous reporting form. And then lastly, we have our commitment to inclusion and diversity. So would love if you could read that in more detail, and please put any comments that you have. And then the other piece of governance that I'm going to walk through is the authorship rules. And so this is also linked in the agenda. It can be a little bit complicated when you first look at this spreadsheet, so I'm going to walk through the pieces. It's not as much as it looks like. So there are 3 of these rows up here with a little bit of guidance. So the idea is, how will authorship be determined, as in who counts as an author, who's named, and who will be listed in the acknowledgements instead, and how is author order being determined, and then also who's going to be corresponding author. And so to be listed as a named author, you have to contribute to at least 2 credit categories. And so if you're not familiar with the credit system, it looks like this. I can drop the link in the chat as well to this specifically. But it's a system that a lot of journals have switched to using. It has these 14 different contributor roles that are defined. And so in the spreadsheet, it has the different roles listed, and you just take a column. We have an example here that's James. You decide this column is me. That's why it says add your name here. You put your name, affiliation, email address, and your ORCID. And then if you contributed to any of these different credit roles, you just put a 1. And if you did not, you leave it as a 0. And so at the end, you end up with a number. And if that number is greater than 2, you're a named author. And if it's not, then you are listed in the acknowledgements. So if it's 1, you're listed in the acknowledgements. So that's how that piece is determined. And then author order is determined in this next section lower down. So there are a few different pieces of the manuscript or the manuscript process that are listed here: conceptual vision, introduction methods, data package. And then there are different numbers that you can list beside each one. And so again, this is all self-reporting. So you say how much you feel you contributed to each section. And so if you feel like you were the leader of this section, like you were really leading the charge, like you were leading the team, then you might put 3. And if you were a big contributor doing a lot of the writing, if it's a writing piece, then you might put 2. If you made some contribution, but it's smaller, you might put 1. And if you didn't really do much of anything, maybe you made a really small edit or 2, you would put 0. And at the end, you'll get a number, and the author order will be determined by those numbers. If multiple people have the same number, then it will be alphabetical within that number. So that is how the authorship will work, and also open to feedback on this system as well. So if I was going to fill this out, I would be like, okay, I'm column C, and I would fill out all my information here, and the next person would be column D. So that's what that system is. Yeah, those are the pieces. So I'm going to stop sharing my screen now. And are there pieces that people would like to talk about in this moment? Or do you want some time to read these and drop in some edits now? That's also fine. If you have some thoughts, we can talk about them. Or if anything was confusing, I can also explain it again.
Hey, Amy, this is Ming. I have well, I don't see my role as an author, but I could help as a reviewer, and I could be critical to the writing. So it may be helpful if you have people of similar mind as a reviewer, so they can give feedback before submission.
Yes, and one of the, thank you for mentioning that. I'm going to reshare my screen. One of the credit roles, it's called writing, but it's review and editing. And so in my mind, I'm counting review of that kind in that credit category as well. So if I was doing that type of reviewing, I would put a 1 in that row.
Perfect.
Yeah.
Yeah. So I didn't see that. Thank you.
Yeah, absolutely. It's a lot of roles.
Good.
Yeah. Any other questions, comments, things that were confusing? And if not, then we will go, I think, to our break so that we have more time for our next section. Oh, yeah, James, go ahead.
So I'm gonna
Yeah.
we'll do a little bit of on the fly change here. So we're
Great.
at 35 minutes. We do want to give people a break, and I think we can use this strategically. So the next kind of like thing we're doing besides break is digging more into the storyboard. And if anyone has, if anyone wants to slow down and talk more about governance, you can raise your hand or unmute and shout or put a thing in the, or put a message in the chat. Please do that. I don't mean to drive forward too fast here. So unless someone stops me, I'm gonna go into the storyboard space here. So I will share screen. I think we can do this for a few minutes, and then break for a few minutes, and then come back into and keep digging in and digging in. So okay, so I showed this before. This is this little summary: rate distribution, spatial patterns, patterns and model guidance, model performance, explanatory variables. And then there's a link to the storyboard right there. And here, why not? If it has it been put in the chat, it just makes it sometimes easier. Not the direct link right to the storyboard. So then let me screen share the storyboard here. So I want to orient people to the structure of this. I'll try to make it a little bigger. Okay, so first of all, from a logistical perspective, and we were seeing in some of the I like, I hope, I wonder elements of people asking for tangibles like timelines and things like that. So here's a first timeline. It'd be great to get at least your initial thoughts in here by July 7th. Of course, this is going to be a long iterative process. If you can't get comments in by then, it's okay. There's going to be plenty of opportunity, but that's a first kind of target. The document permissions are set to allow comments, but not editing at the moment. So you can put in comments on the side. And if, many people are good at Google Docs, but some this may be a new experience. So a little detail with comments. And I've been burned by this multiple times, so that's why I'm going to do this. You comment, you type your comment in, and then if you scroll away and you close the document, your comment's going to be lost. You have to hit comment button and then yay. If you hit the check mark, comment will go away. So anyways, I've seen trouble from that in the past, so just want to help people with that logistical element. And so
And
we're not allowed.
jump on that, James. If the document isn't saving or it tells you something's going to be lost and you think, well, I just added comments and it should be saving automatically. One reason might be that you forgot to hit the comment button. That has happened to me before.
Yes, thank you for that note. That's happened to me many times. Let's see. Okay, so there's again this contact email for anything that's on your mind that you need, that you're wondering, that you're concerned about. Please send us an email. Want to note this, Amy already went over the code of conduct. So if you're in here, you're engaging, you are agreeing to abide by that code of conduct. The data is available. Most of it, at least, we're trying to publish it as we go. But there's an initial data package. It's linked there. And then once we get into the actual storyboard, this title is just a draft. I'm sure it'll change. I don't think we need to belabor that at the moment. But I do want to go through kind of the philosophy of this storyboard for a few minutes here. So, like, why a storyboard, first of all? A key aspect of this, which I think is especially important in a big group like this, is it allows us to be very nimble and efficient and very targeted and structured. All those things are helpful to kind of stay on track. And so the front end of it is very simple. It's just like, this is kind of where we're starting. Why are we doing this? Some simple framing thoughts, very simple summary of the approach. The purpose isn't to really elaborate a lot on those kind of elements. The real kind of core of the storyboard is focusing on what are our real questions? What are our hypotheses? What are the exact figures that we need to generate to test those hypotheses and ask those questions? And there's got to be a correspondence, right, between a question and a figure. It's kind of obvious in a sense, but it helps in my experience, it helps to actually say this and like be pretty direct about it. And so the real main body of the storyboard is focused on that. So here I provided these very simple overviews of these questions. So that's in the slide deck. Okay, question 1, rate distribution. Well, what that actually looks like is, what is the actual question? That's written out here. How do the medians, ranges, skewness, like the moments of the distributions basically, how have those been changing through time? So the initial data came from 2019, but then from 2022 to this year, we've been getting more and more data on this kind of rolling collection. And so what's been the trajectory of those rate distributions? And we have a hypothesis here that digs into some details. We have expected results, but you can see we don't know all the results yet because we haven't done all the analyses. The range of rates in 2019 was, well, we got to then fill in with the result and then fill in with the result. It just follows this kind of philosophy of like, okay, these are the results we actually need to look at. We don't know them yet, but we're going to fill them in. What are the exact figures that are proposed? Okay, 2 kernel density functions overlaid on each other, one from 2019, one from the more recent work. And then compare the medians and likely other moments between the distributions. So this kind of like this structure, this kind of rhythm, if you will, exists across for every question, the same thing: question, hypothesis, results, figures, the whole way down, all the way through question 5. And I know I'm just scrolling past all the material here, but at the end, we have this implications and conclusions. And I find it's very useful to do the thought experiment of what do we think the implications and conclusions could likely be based on what we think the results are going to show us. And so there's five bullets there, and you'll see as you read through these, there's some things that we assumed for now, right? Like we don't quite know because we haven't done all the analyses, but we think we're heading in this direction. Fill in result, like this is very kind of forward thinking and doing the thought experiment. What could this really look like? So this whole approach is, as I said, meant to keep us focused and do a lot of thinking up front so that the analyses are pretty targeted and they lay right together and they're tied very clearly to specific questions and hypotheses. So this is how we try to write manuscripts in general. Don't always succeed in doing it in quite such a structured way, but it's a goal. So what I want to do is I think we're supposed to have a break in a couple minutes. What I'd like to do is just ask for people do people have thoughts, suggestions, comments right now on this overall philosophy of like how we can structure and move forward. And I guess what I didn't say is the idea is after we come back from a break, we're going to go, I think we'll go into small groups at that point for you all to dig in here and look at it, read it, talk together, think about ways to like, oh, we could think about it this way or that way. Or, I really like that question. Okay, that's also useful to put in there of like a up vote or down vote or however you want to do it. But it's, as we said, practically, you're going to do it through comments added right into this document. So we're at the moment, I don't think, unless I'm forgetting something, we don't have another capture mechanism. Like there's not a Google form for like feedback on manuscript. The feedback is in the Google Doc. So Casey, I see your hand and I want to encourage people to jump in if they have thoughts of this overall approach to how to structure and guide us forward. Please, Casey.
And I think there was someone else who had their hand raised too. Mine's real quick. I just think there's some journals that separate the results from discussion and some that combine results and discussion at each figure. So I was curious, is this combined results and discussion? So you discuss the results after you report them?
So at this moment, at least in my view, we haven't decided on that particular, like a combined result and discussion or separate. And I think that, as you know, will depend on which journal this ends up at, which in some ways will depend on kind of like, I don't know, how spicy or exciting the results end up being. That's just kind of how it goes. And so the intent here is to make sure we're linking figures with hypotheses and questions. And then what we'll probably add in is, and this is part of what we'll get to a little bit later, is interpretations. Okay, we got to figure, okay, well, what do we think this means? And getting feedback from everyone. I think it was Ming maybe that was mentioning earlier, like happy to review. That's one thing that's great to get people's review on of like, okay, I think this figure means this. Please review that conceptual interpretation. And so the material, the thoughts, the interpretations, all that stuff's going to go in the storyboard. And then we'll have to decide, are we breaking that into separate results and discussion or combined? So I think that's sort of TBD. Okay, another hand is up. Looks like Bill, please.
Yeah. Hi, Bill McDowell. It would be really helpful. I mean, I did sample in 2019. I think the sampling I did earlier is the 2019, as well as this last year. And I have to say that though I took a bunch of samples, I don't really know the methods. And so when we start framing hypotheses and thinking about what the results mean, it would be very helpful for me if we first highlighted the approaches that were used to generate the data or the possible data, because it was a lot of sampling and clearly a lot of analysis was going to be done. And it would be very helpful to know sort of where we're starting from and even, the definition of respiration, for example. I mean, one can
Sure.
see that referred to with various methods from the literature. So anyway, that would be very helpful for me as someone who's just done sampling and hasn't done any of these other author criteria things to start to wrap my head around it.
Yeah, no, that's super helpful. Thank you for sampling, first of all. Appreciate your collaboration. And yeah, that's very actionable feedback. And we can get those methods, very quickly get a summary of the key methods into this document. And for the moment, I will just very, very briefly, since respiration is it's like the core. I don't have a slide pulled up to kind of show this, but I'll just briefly describe the method for that. So sediments come back to us, they're sieved, usually in the field. If not, they're in our lab to less than 2 millimeters. They go into a 40 milliliter vial. We add native river water that's shaken, so there's no headspace, completely full, capped, there is an oxygen sensitive dot on the side, on the inside of the glass vial. They're shaken, and a fiber optic method is used to measure oxygen through the wall. And then they continue to shake, and then we repeatedly measure oxygen consumption or oxygen concentration through time, and then fit we're just fitting a linear model to those data. The linear model usually works pretty well. And then the slope of that line is considered to be a proxy of respiration. Most directly, it's oxygen consumption, but we're assuming it's primarily respiration. So that is a very brief summary. Hopefully that's helpful, Bill, and to others that may be wondering about that.
Yeah, that's very helpful. That's just the kind of input information that would be useful.
Cool. Okay. Well, I think this is probably there's part of this will be a PNNL action to grab some methods and put them in the storyboard. And Stefan, it might be then useful. I'm guessing people may be wondering about this from the machine learning side as well. You might want to grab some little, a paragraph, I think. It's just to kind of orient people a little bit more. Okay.
Sure, so I can put that right in the doc.
Yes, please. Okay. There's the approach section up here. And I think we can just add hopefully a few paragraphs right in there about some method summaries. In fact, we can just do it right now. Well, not put it all in there right now, but just there's the section. Okay, appreciate that. Any other burning questions? If not, we're gonna break for just a few minutes. And if you don't feel like taking a break, all good. I would suggest, if you feel like it, to dig into the storyboard and start to let those ideas and the material sink in. So we will see people back. Let's just meet at the top of the hour. I think that'll be pretty good. That's a nice, clean, round number. So if you're on the West Coast, that's 9 a.m., but everywhere else, it's whatever hour you're in. So it's in 9 minutes. Okay, see you all soon. Thank you, and looking forward to digging in more to the science.
Stefan, since you're typing, can I take a moment to ask you a question?
Yes, absolutely.
What kind of hydrologic inputs are ingested into the AI model?
Great. So right now, the AI model uses 25 inputs. Some of them are in situ, so measured during the sampling. So things like, there's 3 of them, temperature, pH, and dissolved oxygen. The pH is from a strip, so it's not
Sure.
a super resolution, but
yeah.
A rough indicator. The oxygen is from a mini dot sensor. The other remaining inputs are grabbed from large-scale databases. So in particular, I use the River Atlas database, which has at roughly a 30-meter resolution across the globe. It has things like elevation, annual runoff, precipitation, annual temperature range, a whole variety of things. And so what I've done is for every site, I co-locate whatever data is in River Atlas to that particular site.
So then you don't actually have hydrologic functions going in, which is fine. Totally, this is definitely not a criticism. I'm just understanding because I don't want to put a comment into the storyboard that you're already doing.
What is so I'm an oceanographer by training. What's a hydrologic function?
Well, so for instance, I mean, in the spring, there's more runoff and there's a lot more DOC, and that's going to trigger a lot more. Well, there's 2 things that happen there, right? You have more runoff, but I don't know how that affects the exchange time. There's a lot of, so there's more runoff, there's more water overall. The hypereal zone actually expands, and in addition to that, there's a lot of DOC that comes downriver. So that is going to clearly have the potential to drive respiration in the hypereal zone, and my guess is you probably see that in your AI models, probably picking up on that. And
But from a climatological perspective, so the River Atlas database provides sort of a year-round estimate of what the runoff is, as well as sort of the minimum and maximum values of the runoff. And so I use the machine learning model can see sort of the annual average runoff at that site, as well as sort of the amplitude of the average change over, but it won't see
Yeah,
it for
sure.
just 2019 or just 2022 or something.
yeah, well, but those are still rolled up parameters that capture the average variation between high flow and low flow, right? So essentially the question that I'm asking would be to open up that particular box and dig in a little more specifically, because the amount of water being transmitted, you know, the discharge in the river and the connectivity to the local floodplains, which is where that DOC that drives respiration, where it comes from. That would be just another term in the cumulant expansion of describing that respiration. And you're probably rolling them up now. And that's great. You answered my question. Does that make
Okay.
sense?
I don't know if you can hear. I had exactly the same point, so thank you for raising that. Another angle of that is seasonality. There's sort of the instantaneous temperature at a time of measurement, and is that seasonally, I imagine a lot of biologic functions may be high or low one day, but that day may be out of anomalous within the season. So if we're trying to understand a river or a water body, that seasonal effects could also be important. They're harder to measure because they take a lot more measurements to characterize, but they could be important, I would think.
But I mean, discharge is so easy to get those data off USGS, and that's going to be linked to a lot of those things right off the bat.
Yes, yeah, discharge. I'd probably put that at my first, big variable that we should incorporate.
Yeah.
But I think, say, even seasonal temperature variations and things, that a lot of water bodies are big enough that the temperature doesn't go up day by day. But say in the small streams I work at, they do, and we measure several streams in the same little watershed, and they have different temperatures. So so things can change based on this week's weather and things like that in smaller water bodies. And especially if we're training a model, we don't want to train it to think one way when actually there's a lot more variability that's unaccounted for. So we can define that out of the question, or we can try to incorporate it. So at some point we have to define, what it is we're addressing, and then explicitly say we've left these things out because we're assuming big water bodies or whatever it is. But I think we should think about that and address it, so we know what's uncontrolled variability and what's controlled, or characterized, I should say.
And you can drive that to a further extreme, in the sense that climate variability is going to make a difference in the future, in the sense that even though seasonality is going to be different, the extremes, particularly of high flows and low flows, in a lot of areas are being predicted to be greater, and even though the seasonal amounts might be very similar, so that could be an issue if the model is going to be used to predict the effects of climate change in the future on that. The other thing is, I mean, the point about hydrologic functions is a very good one. And that includes something like, even though the flow, the depth may be important. For instance, you may have more exchange of oxygen from the water with the atmosphere, or any other gases as well, and that may be influenced. The amounts for the same flow may be influenced by what depth that flow is occurring at, and also very simple hydrologic functions, such as like the cross-sectional area and the wetted perimeter. There's a whole lot of scope, I think, for bringing those factors in. Certainly, I think they will have an influence.
Yeah, I think discharge alone may not be able to impact respiration or CO2 outgassing, but actually turbulence or velocity. So that means we need also to consider geometry of the channel, and discharge from the Mississippi River is 100,000 times of that small channel, but that doesn't see anything. So we have to come to another parameter, hydrological parameter, that is probably velocity. You need to consider geometry of the channel and come to a velocity number, because velocity will affect K600, KT, KH, the gas exchange, you know. Mhm.
And so by geometry of the channel, that needs to be that needs to be considered in addition to the velocity together. It's sort of like the Reynolds number, where the turbulence depends on both the size and the speed. Is that right?
Where if you have discharge, if you have the cross-sectional profile, cross-sectional area, so you could easily compute velocity. That is the QVA. That is the velocity is equal discharge divided by cross-sectional area. So you can get an average velocity for a certain location of a river. Yeah. So that number is more responsible for biological activities than just discharge, you know, because discharge varies largely from river to river. Yeah, from Mississippi River, we have here over 10,000 cubic meters per second as to a small headwater with just 1 cubic meter per second. Yeah. But the velocity probably in the headwater is faster, you know. Mm-hmm.
Hi. This is thank you for the discussion and the thoughts. Really, really cool. I love the people are engaging. I'm gonna, I don't want to really shut down, science thinking. I'm gonna maybe channel it pretty soon into small groups so we can really kind of dig in and have a lot of people have opportunity to contribute in these ways. And based on the conversation and thoughts I'm hearing, something that I think is really would be a great topic for y'all to discuss once we go into some small groups in a couple minutes here is thinking about the scope of this paper in terms of the implications and where the boundaries are. And so going back to Bill's question earlier, like what are some of the primary methods? Something I think that's really important for us to be collectively thinking about and being very conscious of is the limitations of the data that we're using here, right? So we're, as I mentioned, sediments, fine-grained sediments, only the material less than 2 millimeters comes back to us. And that's the only thing we're measuring in terms of a rate. And it's all in the lab and it's all under standard conditions. So we're not replicating field temperatures or anything like that. This is very much more focused on kind of fundamental rates, possibly rate parameters that can be used in mechanistic models or even in machine learning models as a foundation in a sense towards trying to better understand spatial and temporal variability in situ respiration rates in rivers, but we have to be careful, right? Because we're not measuring anything in situ in terms of rates. And so I'd encourage it when you go into in your small groups, this might be something to be thinking about of how far can we push these kinds of data and where should we draw the lines and just be okay that, we can't solve everything. So just anyways, just kind of putting that in our minds for y'all to discuss. And so I'm kind of feeling like since we've been over the storyboard, kind of looked at the structure, an idea of the kinds of questions, I'm seeing people that have been in there to a certain degree. I'm feeling like it'd be a good time to go into the small groups. And the intent of these, as I said, is to share your thoughts. Read a little bit more in the storyboard, share your thoughts about this question seems weird or good or whatever it might be, or we can change this hypothesis. And as you do that, all kinds of thoughts are appreciated. Please put everything in your mind in there. We have 20 minutes scheduled for these small groups where y'all be together, discuss, communicate, add comments in, and then we'll have a little bit of time. At the agenda has 5 minutes. Oh, we might be able to increase or decrease that of just time on your own after you're meeting with the group to just like collect your thoughts a little bit, okay, and then like add a little bit more in the document if you like. And then we'll come back in this bigger room with everyone to have a look at what comments are coming in into the document and have some broader group discussion. And then the last thing we'll do is talk about the next steps, kind of practical elements. So does that sound okay? Maybe I'll ask this question. Does anybody want me to go through the storyboard more right now in this bigger group? If you'd like that, I'm happy to do it. Raise your virtual hand so I can see it if you want me to dig in a little bit more to the storyboard. I'll just give people 5 or 6 seconds to do that. Okay. Okay, so one last thing before we go into the these breakouts. As you're going through here, I think I saw something like this in when we did the initial breakouts. People are just getting to know each other. If you're seeing an opportunity for another manuscript, or maybe a couple more manuscripts, that's awesome. Like we would love this to spin into multiple papers. There's no reason to keep this to just one paper. It would be a wonderful outcome if someone wanted to spin off and lead another paper that's complementary. Super, super encourage that. Part of what we're trying to do with all of our work, in particular with respect to our WHONDRS Consortium, is find ways to enable other people and to give back. And if there's opportunities that you're looking for that we can help provide, leading manuscripts, doing analyses, whatever it might be, please let us know. So keep an open mind, a big mind. If you want to write another paper with these data, go for it. So, okay, I'll stop talking. I think we should go and have discussions amongst ourselves. So you're gonna get swept away into small breakouts. There'll be 3 or 4 people. Dig in the storyboard, discuss, add comments. The more we do right now, the richer it's gonna be. That sound okay? Anyone have questions? Okay, all right. Bree, are you hitting the button to?
Yep, they should start to be pulled in.
Okay, enjoy. Look forward to seeing your thoughts and comments. Appreciate it. Okay, wonderful. Thank you all. I've seen a lot of comments. We tried to respond to a few of the comments that are in the document, and certainly couldn't get to all of them, but a lot of very useful thoughts in there. Appreciate that. So there's 2 ways we can go right now. We can spend a few minutes just like quiet time for each of us to be kind of like let our thoughts kind of sink in and add more comments to the document. That can be useful if you are in very lively discussions to like have a moment to yourself to like reflect and add some thoughts. Of course, different breakout rooms are going to be different if you're mostly doing that already. May not have a lot to do, I don't know. Would people like to have a few minutes to just like reflect on their own and add some more thoughts in the, can you raise your virtual hand, or if you're on camera, raise your physical hand if you just want a couple minutes to like reflect and add some more thoughts? I see 1, 2, I think 3, 4. Okay, 5. That's probably enough. There, I know there's going to be variation in what people want to do here. So let's do this. Let's take 5 minutes. We're just going to be quiet. It's going to be weird in a virtual setting, but we're going to do it. We'll take 5 minutes, reflect on your own, add some thoughts, some comments, please. And then we will come back on to microphone at 36 after the hour. And please stay muted until then. Thank you. Okay, so we are at 5 minutes of alone time. And okay, lots and lots of comments. I was starting at the top and trying to respond to some of them. Nowhere close to finishing. So the next thing that we have on the agenda is time to kind of think collectively here. The idea is to go till 45 after, and then we'll talk about practical logistics. So Stefan, I think you're up to help with this part to facilitate.
Absolutely. Just quick, I want to do a lot of listening. The only thing I want to start off with saying is that in the previous discussions, there was a lot of question about what exactly are the inputs to the machine learning models. And I just want to warn everyone, I'm about to put a long list, paste a list of those 20 something inputs to the model into the planning document. So if you see your Google Doc jump in the next second or so, just be prepared. Just be prepared for that. Okay. So I should have just done that. Fabulous. So I've been absolutely thrilled with all the yes. Okay. So James, thank you for noting, capture your comments, thoughts, etc. into the storyboard. There's been a tremendous amount of feedback, and I've been taking notes during the small group sessions, but I'm certain that there's lots and lots of other thoughts that are percolating in the other small group sessions. And so really what I'd like to do is make a space for folks to bring out feedback about the sort of the science and like the sort of the scientific aspects of and the overall plan that we have. So if nobody says anything, I can bring out comments that I've already picked up, but I just wanted to let folks raise their hands and sit and bring out what you'd like to bring up. So I see that there's already a hand raised from Walter.
Yeah, so my point's kind of a high level conceptual one, and we're throwing out the terms hotspots or control points. And I went into the conceptual figure that James put linked to. And so I threw something in the chat that sort of recreates that. And you can see that basically what they said is that yellow curve versus essentially a log normal distribution. But when we make these words points or hot spots, I think of it more in terms of a binary thing, not a distribution of rates. Right. So just getting a log normal distribution of rates doesn't mean we necessarily have hot spots per se. We just have a different distribution. But if we have one like the red dashed line in there, then we have a bimodal distribution, and in some places that have super high rates, right? And so that would be, if you drag to the right of that chat, you can see the rest of that image that I threw in there.
So I'm sorry, but I can't see an image there. It might have been in the small group chat, which may have been a different chat space.
Huh. I see it, maybe, I'm sorry. There. I didn't send it.
Fabulous, thank you.
That's that same thing that you get with editing a Google Doc and leaving with a comment. Okay,
thank you.
Yeah, so the yellow's the normal, right? The green's the sort of log normal distribution. And that red dashed one is where I'd say, okay, that stuff on the right, that's a hotspot or a control point. And I don't know how we, define that particularly, but I think people throw terminology around in a little bit inaccurate way, because both a spot and a point suggests there's some sort of one thing. It's not a continuous distribution. So it'd be nice to look for that and talk about the distribution of rates. And then the other thing I'm a little bit hung up on is the idea that if you do this over a huge database, what does it mean in terms of respiration? So like, let's say we've got a couple rivers that are super high respiration rates, much higher than, like the orange thing. So does that mean they're just processing a bunch of carbon and it doesn't make it out of the system? You know, and then I'd say that's a cold point in some ways. Is creating. I mean, why does it matter that we're looking at respiration in these things? Are we trying to say, okay, does it matter as far as carbon flux, or does it mean that it's going to be a high CO2 flux river relative to some other ones? But so I'm just sort of trying to think at the top level of how we come about this. But oh, I'm sorry. The X is the rate. On the x-axis, the way they had it is just some rate, you know, milligrams oxygen per cubic centimeter per day or something or other, right? And it's a frequency distribution. What Corinne said should be put in the other direction, and I can kind of see that, you know, conceptually. But
that's my bad, because I read frequency is like how frequently does it occur. I thought of it as over time. So that's just, like I said, that's me not being locked in my like tunnel vision of what a graph should be.
Spot, I suppose, or whatever. Yeah. But yeah, it's yeah, shifting the response variable to the x-axis always makes things weird. But just an idea to throw out there. I'm not set on it.
Great, thank you very much. I also see that Michael has a hand up.
Yes, just to confirm that in our group with Errol and Emily, we also thought that focusing in on the hotspots, or whatever you want to call them, the other end of that bimodal distribution, it was very important, because not just for what you already said, but also for defining what sort of sampling strategies are necessary to capture that, if you're going to calculate even long-term averages or even seasonal averages from that sort of data. If there are these short duration, spatially localized hotspots, then you know it's very difficult to calculate long-term averages, and far more may be happening than we're aware of. But so that, just to confirm, that's the interesting area, I think, that we thought was necessary to focus on.
Absolutely. Thank you. And Bill, do you have a comment about that?
Yes, following up, I put something in the document too, but I would be really interested in understanding more about the extent to which the process by which sample sites were chosen, like along the way, you know, it was a shifting target, of course, as to what sites we would try to sample as a collaborative. To what extent, or how can we assess to what extent that sampling strategy may increase or decrease the, I'll just say, the hot spot occurrence, for want of a better word. But you know, it seems that the hot spot, hot moment concept was not built on, you know, going out and sampling the way some AI algorithm tells you to sample. It was built on some, you know, raster or some other approach.
Great, thank you. James, we are running, I'm just noting the time. We're supposed to end at 45. Can we keep going, or do you want to?
Yeah, let's go for a couple more minutes. And I just put something in the chat. Just want to make sure everyone sees that we're not like engaging. All these things that are being raised are like big conversations. So we're not really engaging at the moment. That's not because of lack of interest. We're just trying to hold space for many voices. So totally hear what you're saying, Bill, and I can hear like, oh, maybe there's a bias, and we're like shifting the distribution in a way that's maybe not purely random and natural. So I'm hearing that, but I'm not like going to engage deeply at this moment. But thanks for contributing, and it looks like there's more hands.
Yeah, I see two more hands. Yijun?
Yeah, I was wondering if you could put a summary table with sampling number, the size of sampling under each large river basins. So like Mississippi River Basin, Hudson River Basin, Colorado River Basin, or some major river basins. And that'd be very helpful for me to think about a hypothesis. Yeah, what are the major hypotheses do we want to test with such a large data set? Do we want to test hydrological control on respiration, or do you want to test land use effect or climate change effect? What exactly do you want to test? So I think with the information about sampling number under each large river basin would be very helpful. Thank you.
Great, thank you. And Mehan?
Yeah, so my concern is the biggest strength of this project is we have huge data points across the space, but the challenge is about the temporal um, resolution. So is there a way we can, the way Yijun said, uh, we can cluster it on the basis of uh, some kind of low stream, high stream, headwater, downstream situation, rather than lumping all together for the entire corners where things can be mismatched because we are not taking any geomorphological characteristics. We are not considering any hydraulic, means though we are putting everything in our model, but we are lumping it. We are not making it discrete for aerial consideration. So just a thought that if we can bring that together, I think that will add a lot of strength to this project since we have excellent spatial information.
So like separate models for separate domains.
Yes. And that would give a very meaningful information to the whoever is using it.
Great, thank you. So I don't see any other hands up. And I want to make space. We've only got about 10 minutes left. James, do we want to take a last call for any comments and then move on to final discussion?
Yep. I'm gonna start sharing my screen and we'll talk about some proposed progression elements. And I think there is a Google form for this part as well. Bree, or someone can throw that in the chat as I share screen. Okay. So, okay. So 10 minutes left. Thank you all. There's so much, there's a lot of rich thoughts and comments. Super appreciate that. And Corianne, I see your comment in the chat. We can get that into the Google Doc. Be awesome. I captured a couple of things at the kind of the approach section of the storyboard. You might be able to add that right there. Okay, so practical things. We would love for people to keep commenting on the storyboard. It would be really great to get your thoughts by July 7th. If you have more thoughts that are coming as you're reflecting on this over the next couple weeks, this is how the paper will become amazing, is to have all thoughts from y'all. So then this is a proposed kind of rough timeline. We can change this and would like to get your feedback, and the Google form has some elements to respond to with respect to like what kind of timelines are reasonable. I just very much encourage people to engage with that. Bree put it in the chat. That's how we can get your feedback on the logistical elements. So the idea then is like, okay, we have comments, great. And then mid-July, starting maybe to mid-August, we'll see how that goes, but starting in mid-July, based on changes we make to the storyboard, tweaks we make to specific questions, hypotheses, figure needs, we actually start generating figures. We've been working with the data as it's been coming, and so we're in a pretty good place to start generating figures. And one thing that I want to encourage people to do is, if you're interested in helping to generate figures, writing code, helping with tweaking figures, whatever that might be, if that seems appealing to you, I super encourage you to reach out. Heard from one person today that that's something that they're interested in helping with. Please email us. It's right there again, to wonders@pnnl.gov. If you want to help get in and start working with data, totally open to that. Very much encourage it. Please reach out and let us know. Then we'll see how, generate figures, see how that goes. As those figures come, they're going to go into the storyboard. And so let's say maybe around mid-August, figures are coming, the storyboard's filling out with figures. Really we're hoping to get people's feedback on the interpretations of those figures. What do these mean to people? And all thoughts are welcome. I think how we'll do this is every figure will have a little section under it that'll be like interpretations, and people can directly put their thoughts in there, and we can asynchronously, to begin with, add in thoughts and suggestions and modifications, etc. Literature that is relevant, super helpful to drop that in there as comments or direct edits. And we'll continue to do that. And at some point, we kind of have it roughed out here as like maybe mid-November. We need to move beyond the asynchronous approach and start to engage with more direct meetings is kind of the vision. These timelines are very rough. I'm sure they're going to change. But the idea is, once we have enough figures in there, we have enough kind of conceptual interpretation, we've got lots of comments and things, let's get back together and dig in some more and keep iterating a little bit more direct interaction. And that will take kind of as long as it takes. We're hoping that maybe mid-November, maybe that's ambitious, where we will have gone through some iterations together in terms of how to interpret what we're seeing. Probably that leads to new analyses that we didn't envision to begin with, is a likely scenario. And then at some point there, maybe it's mid-November, maybe it's a little bit later, the idea is for whoever wants to continue to contribute, start to break into different teams, writing teams. This is a common way that we tend to work with these sorts of open collaborative papers, is sort of what we think of as a distributed leadership approach, where there will be a group of folks that are really interested in writing the introduction. Like, they want to frame this paper, and ideally there'll be one or two kind of leads, point people for that, and then additional folks want to contribute to the writing. Same thing with the methods and the results and the discussion, or maybe those are combined. We'll see, as was mentioned before. But basically, kind of see who wants to help in what kinds of ways, and likely build out sort of sub-teams. And those sub-teams ideally will themselves have recurring interactions and meetings, some asynchronous work, but also some meetings to discuss, to dig in, maybe co-work. Different teams like to work in different ways. And we'll keep doing that basically until submission. Mid-February is a target. That may be ambitious. We'll see. And as noted in the very bottom there, that machine learning AI methods manuscript. So that's one I was mentioned before. So that's Stefan and Tim Scheibe are leading that one, and that's kind of laying the methodological groundwork in terms of the modeling part of this. So we'll be able to cite that paper and not have to worry too much about having a big machine learning methods section in this particular paper. So that's kind of the roughed out idea. Would very much like people's feedback. If you're seeing issues, gaps, some way to do it better, love to hear it. We're all ears. Any concerns? So do the raise hand and shout. Or if people are like, this seems pretty good for now, good enough for now, there is a react button and you can do a thumbs up. That's also helpful because crickets are difficult to interpret. Yes. Oh, was there? Oh, okay. Great. I do see a hand. Maybe it's Michael. Did you want to jump in with a comment, or is that meant to be a yay?
That was meant to be a thumbs up. I'm sorry.
All good. All good. Appreciate the feedback. Okay. All right. Well, okay. Yes.
So
Sushan?
James, I just want to thank you. I have worked with a lot of scientists. With first my first icon manuscript was with 14 different scientists from 14 different countries also. The for open and icon section. But thank you for being so transparent and looking forward to working with you all. Means this is really going to be a great work. Thank you.
Thank you for that feedback. Thanks for your contributions to the icon collection as well. Yeah, I hope people continue to have useful and positive experiences. These are engaging, sometimes challenging, but hopefully ultimately useful to folks and hopefully a good time as well. Yeah, thanks, Sushan. Okay. Anything else from anybody? The next action is, as noted here, please keep contributing thoughts to storyboard. Email us directly if that's better. If you want to have a direct meeting with us, you're like, I got this thing, we just got to talk through it. That's great. Email us, please. wonders@pnl.gov. We'll find a time to meet with you, dig in, whatever the mechanism is that you need to contribute, we will make it happen. So thank you very much. Appreciate it. Hope you all have a great rest of the day. Hope the weekend goes well. And take care. Talk to you all soon, I hope. Bye-bye.